Sir, can you give us an example about type 1 binary compounds?
Yes, sure. So we have Rb2O as a given. Rubidium oxide. Rb in table of elements is called rubidium, and oxygen for O. Rubidium have the charge of +1, while oxygen have the charge of -2. We do criss-cross method in type 1 binary compound, so Rb have the charge of 2, and oxygen have the charge of 1. Rubidium belongs to alkaline metals, while oxygen belongs to nonmetal. So it will end in "ide" as a suffix. Name the cation first, then anion. Anion name by taking the root word of the element, then add "ide" at the last part. The name of the formula will be rubidium oxide. Next, let's find the chemical formula for rubidium oxide. To find the chemical formula of rubidium oxide, find the symbol of each element in periodic table of elements. Rubidium has a symbol of Rb, and its oxidation state is +1. Oxide is for oxygen and has a symbol of O, and has an oxidation state of -2. In this type, we can use criss-cross method, so the answer will be Rb2O.
Next given, we have MnO2, which is a type 2 binary compounds.
Ma'am, can we use crisscross method in that example?
No, we can't use crisscross method here.
In this example, we have a formula MnO2. To name this formula, we will need to name the cation first, then the anion. Our cation is Mn, which is known as manganese, and our anion is O, which is known as oxygen. Always remember that the anion is named by taking the first part or the root of the element name, then changing the last part by IDE. So, for oxygen, we will take the first part, ox, and then change the last part into ide. So, we have oxide. As you can see, we now have manganese oxide. So, to figure out what our Roman numeral is, let us see the overall charges. You can determine charges by using the periodic table. For oxygen, we have a charge of -2. In order for everything to add up, we have 2 multiplied by -2. The product will be -4. That means Mn or manganese is gonna have to be +4 in charge. Because we have +4 in the manganese, we have to put 4 in a parenthesis and disregard the oxidation state of the anion. That being the case, our overall answer will be manganese 4 oxide.
Now, we will use manganese 4 oxide as the formula.
For the next example, we will now do the opposite. We will determine the chemical formula of manganese 4 oxide. Use the periodic table to determine the symbol of the elements. You will know that manganese has a symbol of Mn and oxygen has a symbol of O. Then, what we will need to do is to write both of the symbol. To determine the charge of the elements, you can use the periodic table again. If you look at the given name of a compound, Manganese is a transition metal, so the charge is already written. We can easily conclude that manganese has a charge of positive 4. If you look at the periodic table, you will know that oxygen has a charge of negative 2. As you can see, we now have Mn4O2. Manganese, which have an oxidation state of positive 4, and oxygen, which have an oxidation state of negative 2. The least common multiple of 4 from manganese and 2 from oxygen is 8. Now, we need to divide 8 by 4 and the answer will be 2. Divide 8 by 2 and the answer will be 4. It means that the answer is Mn2O4. But as you can see, we can still simplify it to MnO2. So, the overall answer or the formula of manganese 4 oxide will be MnO2.
Ma'am, can you give us an example about type 3 binary compound?
OCl2. Find the chemical name for each element. The chemical name of the symbol O is oxygen. Since there is no subscript written beside it, it is automatically equals to 1. Next, the chemical name for Cl is chlorine. Change the last part to IDE, so it will be chloride. There are 2 atoms present, so we will put the prefix di, which means 2. We should put it together so we have oxygen dichloride. Let's change the given to its chemical name. The given will be oxygen dichloride. Find the chemical symbol for each element. The chemical symbol of oxygen is O. Since there is no prefix before oxygen in the chemical name, therefore, there is only one oxygen atom in the chemical formula. Dichloride has the prefix di, which means there are 2 atoms present. Chloride is derived from the word chlorine, whose symbol is Cl. Therefore, there are 2 chlorine atoms in the chemical formula. Put it all together so we have OCl2. The given is SnOH2. Let us name the ions first. Sn is tin in periodic table of elements, while OH is polyatomic ion, stands for hydroxide with negative charge. Remember that tin requires a Roman numeral since it is a transition element. The Roman numeral comes from the charge of an ion. To find it, let's get back to the given. SnOH2. Tin is equals to Sn, has an oxidation state of positive 3, while hydroxide has an oxidation state of negative 2 because there are 2 hydroxides. To find their LCM, tin has 3 charge, while hydroxide has 2 charge, so their LCM is 6. For tin, 3 divided by 6 equals to 2. And for hydroxide, 2 divided by 6 equals to 3. Disregard the charge of hydroxide, then the answer will be tin 2 hydroxide. Our next given will be tin 2 hydroxide. Let's find the symbol for each element. Tin is Sn and hydroxide equals to OH. Tin has an oxidation state of 2 in according to its given, while hydroxide has -1. Find its LCM. Since tin has +2 and hydroxide has -1, therefore their LCM is +2. For tin, 2 divided by 2 equals to 1. For hydroxide, 1 divided by 2 equals to 2. Therefore, the answer will be SnOH2.
Sir, for sure your example will be boric acid. The name of an acid is based on the name of the negative ion that is part of the acid. This formula will turn into this formula. This formula stands for borate. In naming common acids, when an ion ends with "ide", it should be like this. The root word of the element, "ic", acid. When it ends in "ite", it should be like this. The root word of the element, "os", acid. And lastly, when it ends in "ate", it should be like this. The root word of the element, "ic", acid. Since our example is borate, which ends with "ate", we will use this one. Then the answer will be boric acid. To find the chemical formula of boric acid, since boric acid came from this, therefore it ends with "ate". So it is called borate. When you look for the polyatomic anion table, borate has a symbol of write H at the beginning of the formula, then balance the charge by using crisscross method. The answer is H3BO3.